What's up, dogs? All right. Just got home. It's 5 o'clock the night before your test. We didn't have our review 8th hour due to the lockdown thingy that we just went through. Now, River Dog Jenny very much wants to go play outside, but I told her, hey, we got to do some math because these kids had questions. Right, Jenny? I think she's a little bit pouty. Anyways, I'm going to work through this entire review. Feel free to skip around, get to the problems that you know. I'm just going to go in order. So just guess as to where I'm at if you're going to skip through things to see a particular problem done. I really hope you guys use it. So without further ado, let's see if I can get this. There we go. Make myself smaller so I'm not in the way of the math. Ah, there we go. Lovely. Perhaps I'll go up here. I don't know. I've never been. Woo. All right, cool. Let's go. So first one here. And I will try to let you know if it's going to be a non-calc or a calculator type problem. That's going to be in the way of some of my... Whoa, where'd it go? I don't know. All right. So for this first one here, we need to solve. So I'm going to solve using square roots. All right. So I need to subtract 81 from both sides. And then I would have x minus 8 squared equals negative 81. Now, if I square root on both sides, and I'll zoom in on this particular problem, let's see what we got here. Well, square root of negative 81 is plus or minus 9i, right? Square root of 81 is 9. Negative's in there. We've got to have that I. Beautiful. X. I don't need that parenthesis anymore. X minus 8. So I'm going to add 8 over, and I can't really put this all together, so I'm just going to leave it as 8 plus or minus 9i. Lovely. Definitely a non-calculator problem. Non-calc. Over to 2. Again, a non-calc problem. So I'm going to divide by 2 first. And I apologize if I'm going too fast, but I got things to do. I got to go mow my lawn. Okay, and River Dog Jenny want to play. Well, she's just chilling for right now. Okay. All right. So I've got x minus 2 quantity squared equals 25. Square root, x minus 2 equals plus or minus 5. No negatives this time. Whoop, whoop. I'm going to add 2 to both sides. Now, when we do this, I get x equals 7, because 2 plus 5 is 7, and I get x equals, well, 2 minus 5 is negative 3. America. Wonderful. Moving on. Problem number 3. If I make a mistake, I'm so sorry. Okay, maybe I should pull up the key just so I don't make some kind of a dumb mistake here as I'm trying to fly through this bad boy. Anywho, I guess I'm just going to keep going. All right, solve by factoring. We love factoring. My favorite. So what multiplies to 45 and adds to 14? Well, off the top of my head, how about 9 and 5, yo? So 9, 5. That multiplies to 45. Multiplying by 9s were my favorite in elementary school. And then we're going to add those two together to get 14. So I'm going to have x plus 9, x plus 5 equals 0. Generally with quadratics, my go-to is factoring. All right? But we can't always do that all the time, as we've seen as we progress through the quadratics unit. So x plus 9 equals 0, so x is going to equal negative 9. X plus 5 equals 0, so x is going to equal negative 5. Factoring is your friend. Moving on. Number 4, solve by completing the square. Woo! So although we could possibly do this in other ways, quadratic formula, who knows, maybe it's factorable, I don't know. The directions say solve by completing the square. So we got to do that. All right, so first off, I'm going to add that 8x over here. So x squared plus 8x, but I'm going to leave a little space. And then I'm going to have that 6 over here, and I know I got to add something to both sides. Swapping colors for this one. Boom. A little purple action. All right, so I'm going to take that 8, that b value, divide it by 2. About a squared. So I got 4 squared, and as you know, I like to write all these out because that 4 is going to be in my factor. So I get 16. 16 is what I'm adding to both sides. Woo! So now, in my factored form, back to this wonderful vibrant color here before I change again if I so feel like it. I got x plus 4 quantity squared equals deuce. 6 plus 16, I believe, is 22. I really hope I don't make some kind of a dumb error. All right, square root on both sides. Now I have x plus 4 equals the square root of 22, plus or minus, my goodness. Almost did. All right, got to have that plus or minus when I'm solving using square roots. I'm going to subtract 4, and I get x equals negative 4 plus or minus the square root of 22. That's dope. That is dope. All right, awesome sauce. I think there's one more over here. Ooh, find the vertex of the parabola. Awesome, wonderful. I need some water. need some water. Alrighty. So if we want to find the vertex of our parabola, or as some students like to call it, the parabola, don't do that. Okay. I'd have x equals negative b over 2a, right? Where I've got a, b, and c for like all those awesome formulas. Well, let's go ahead and plug that in. So I'm going to have x equals negative 2, or sometimes people say the opposite of b instead of negative b to not confuse and think it's always negative. All right, over 2a, 2 times 2. So I'm going to get x equals, let's see here, 2 divided by 4, which equals 1/2. Wait, hold on. Almost made a dumb mistake. That's a 1. That's a 2. That's a 1. 1. That was close. Okay. So my x value is 1. How do I get my y value? Well, my answer I know is going to be 1 comma something. If I know the x value, I can substitute it back in to get my y value. I'm going to notate that in proper function notation here with plugging in a 1, substituting in a 1. And let's see here. 1 minus 2 is negative 1. Minus 3 is negative 4. Bingo, bango. There's my answer. Alrighty, time to move on. Jenny's leaving me. Jenny, where are you going? Okay. Well, oh well. We'll get her back here in a little bit. All right, so let's graph this. And it also asks us to complete the square. So we're going to write it in vertex form. Cool. I'm gonna move off to the side here for a little bit of vertex form action. So if I subtract 3, I'm going to have y minus 3. I'm going to leave a little space. X squared plus 4x. And then I got to divide by, or I got to take my b value, divide it by 2, and square it. And I'll do that in a different color. There's a little bit of side work here. So we got 4 divided by 2 squared equals 2 squared, which equals 4. So I'm going to add 4 and add 4. Some of you might be able to do that in your head, but I like to write it down. All right. So I get y plus 1 equals, and then we'd have x plus 2 squared. Lovely. Now, to get it in vertex form, I'd have y equals x plus 2 squared minus 1. And of course, with this one, I could have just done negative b, or opposite of b divided by 2a, and got my vertex by plugging back in like we just did in the previous problem. But this one did specifically say complete the square. So I'm doing that. Well, my vertex from this would be negative 2 comma negative 1. My axis of symmetry is that x coordinate of the vertex. So x equals negative 2. Don't forget that x equals. That's a half point off. It's not just a number. It's an equation of a line, okay? So have some class. Put the x equals in front. My zeros. Oh, geez. Oh, geez. We got a couple options here, okay? We could either factor the x squared plus 4x plus 3, which it is factorable, or I can use this wonderful vertex form. Perhaps I'll show you both for fun. Are you ready? Because sometimes the vertex form is actually a little bit easier. Check this out. So I have 0 equals x plus 2 squared minus 1, right? Because I'm trying to find my zeros. I'll add 1. X plus 2 squared. If I square root on both sides, I get plus or minus 1 equals x plus 2. So I'm going to have 1 minus 2. Let's see here. Actually, I'm going to rewrite that one more time. Negative 2 plus or minus 1 equals x. A little backwards, but whatever. All right. Negative 2 plus 1 is going to be negative 1. And negative 2 minus 1 is going to be negative 3. For our zeros, it's where it crosses the x-axis. If it asks for x-intercepts or y-intercepts, those should be ordered pairs, okay? Lovely. So, boom, there we go. You may also see that if I factor this, and let me do this in a different color here since this is slightly different. If I did that, I would have, let's see here, 0 equals x squared plus 4x plus 3. Well, what multiplies to 3 and adds to 4x plus 3? And x plus 1. So I'd get my negative 1 and my negative 3 that way. Now, that may have seemed a little bit easier, and honestly, I think that is a little bit easier. But in the event that we're not going to get nice integer answers, and perhaps you would have needed to use the quadratic formula, completing the square and solving from that vertex form is actually a little bit easier, okay? But you got options. I love having options, right? It's like, do I want tacos or do I want enchiladas, right? I'll have both, okay? Transformations. What the heck does that mean? Well, from vertex form, which is right here, That is showing that we're going left 2 and down 1. Awesome. That's all it's asking. Beautiful. Did it ask us to grab? Oh, it did. Look at that. So I'm going to pop my vertex on there. Let me get this a little better. There we go. My vertex, -2, -1. Whoop. All right. My axis of symmetry. My zeros, -3 and -1. And then actually for my original, I could get my x or my y-intercept, excuse me, of 0, 3, right? That bad boy right there gives me that. And I can reflect that over. Yes. Wonderful. Cool. Dope. Moving on. All right, we got ourselves a little more solving here. So solve by taking the square root. I'm just going to notate my time here. We're right about the 10:45 mark. That way, I can maybe put that in an announcement and say, hey, second page starts at 10 minutes, 45 seconds. So I can save you guys time. How wonderful am I? Yes, okay, wonderful. So solve by taking the square root. I'm going to square root on both sides. And I get x minus 5 equals plus or minus 8. So I will have x equals 5, if I add 5 over, plus or minus 8. So I'll get x equals 5 plus 8 is 13, and 5 minus 8 is -3. America. Moving on. All right. Went to the post office for the first time in a long time today after school, and I had to mail some things, and I went and said, hi, I need to mail these, but I'm a millennial, and I don't really know what I'm doing. Can you help me? They helped me. It was great. It was a wonderful experience. Okay. Solve by factoring. Oh, my gosh. A leading coefficient. Those are so terrifying. Not for me. All right, so -60. Here, I got to add to 7, right? I got the -60 from 4 times -15. YOLO. Okay. So what multiplies to -60 and adds to 7? It's got to be a positive number and a negative number. Whoa, what would that be? Let's see here. I got 6 and 10. That's not going to work. 3 and 20, no. I mean, these are the ones that are coming to mind first. Ooh, wait, hold up. 60 minutes in an hour. There's 12 hands. 5 minutes in each. 5 and 12. My goodness. You don't have to worry about the clock thing. That was just me thinking, okay? So it's got to multiply to -60. So -5. That would add to +7. All right, let's break this apart. 4x squared minus 5x plus 12x minus 15. And I'm going to be honest, I did pause the video to think for a second because I didn't want to sit here and think about those. My brain is fried. All right. I'm going to pull out an x. 4x minus 5. I'm going to pull out, let's see here, a 3. That leaves me with 4x minus 5. Okay, that's good. Things are rolling wonderfully. X plus 3 is one factor. 4x minus 5 is the other. So I'd set those equal to 0. X plus 3 equals 0. So I'm going to jot that over here. X equals 3. Sorry, -3. And then 4x minus 5 equals 0. So I'd get x equals 5 over 4. Yes. Dope. Wonderful. Fantastic. All right, I'm going to try and get Jenny involved in this one. What do you think, Jenny? No? Are you really going to leave me after I just walked over here? Come on. Okay. Let's see here. Solve by any method here. What do you think, Jenny? She's just bored. Well, with this one here, since Jenny wasn't a big help, I'm thinking square roots because it's already got a binomial squared. If I add that 36 over, this looks like a pretty, yeah, pretty wonderful. My marker's not writing. We're okay. X plus 4, 36. I thought I had a freeze up. Thought it froze up on me. If I square root on both sides, I'm going to get x plus 4. I don't know why I wrote that parenthesis again. Equals plus or minus 6. So now I have x equals -4 plus or minus 6. So let's do them one at a time. I'm going to have -4 plus 6 equals 2, and -4 minus 6 equals -10. I'm done. That was awesome. Super easy. Mildly, right? Had a couple things. Number 10. Leading coefficient. Well, I can go quadratic formula with this, or I could try to do factor with a leading coefficient. I'm going to see if this thing is factorable because I think it is, because I'm kind of a genius. Not really. All right. So what multiplies to -6, 3 times -2 gave me that -6 that I need to multiply to. What adds to -5, my middle term? Well, that would be -6 and +1. So this is factorable. I can avoid the quadratic formula. How wonderful. So now I have to break it apart again. minus 6x. So if you didn't get that last one, perhaps this one will make you happy. Okay. Group them. I'm going to take out a 3x, and I'm left with x minus 2. And then I can take out nothing, so I'm going to pull out a 1 as a placeholder. And then I'll have 3x plus 1, and I'll have x minus 2 equals 0. So I've already set equal to 0 and solved and all this. I'm going to just go right for it, save some time. Negative 1 over 3, and x equals 2. Awesome, wonderful, fantastic. Moving on. Almost missed number 11 by accident. All right, let's see here. I need to set this equal to 0 if I'm going to solve by factoring, and I think that's, again, going to be the easiest method. So let's see here. X squared minus 9x plus 20. My go-to is always factoring first for me. If you like to avoid that kind of thing, it's okay. Whatever, man. You know, maybe one day you'll like it, just like me. So what multiplies to 20 and adds to negative 9? It can be 2 positives or 2 negatives. It needs to add to a negative, so it's got to be 2 negatives. How about negative 4 and negative 5? Woo-woo! All right, so x equals 4, and then x equals 5. Again, I'm skipping a step with setting them because there's not a whole lot of room, and I want to save some time. Whoop! Awesome. Lovely. Oh, man, use completing the square to put into vertex form. So you'll have something similar like this on your test where you have a leading coefficient that you got to deal with. Obviously, we got to take out that GCF at some point, just like we did in class. Let's go for it, shall we? Awesome. I'm going to switch colors. The purple, although I do enjoy it, has become a little bit monotonous here. How about some green? I love me some green. All right, I'm going to add 7. So I have f of x plus 7. And then I have 2x squared. I'm gonna take out that 2 right now, save a little space here. 6x, and then I'm gonna complete the square there and there, right? Okay, everything looks good so far. I added the 7, took out my GCF. B divided by 2, so 6 divided by 2 squared, that's 3 squared equals 9. So I'm gonna add 9 here, but what am I really adding? I'm adding 2 times 9, which is 18, okay? 2 times 9 is 18. That's what I really added on the right-hand side. So to balance, I got to do that. So I have f of x plus 25 equals 2. And then when I factor this, it's x plus 3 squared. It's always going to be that little guy right there. So if you're dealing with a fraction situation, you're like, dude, how do I factor that? Well, that number that you squared is what goes in the perfect square binomial. Okay? Lovely, fantastic, wonderful. Vertex form. I'm going to subtract that 25, so I'm going to have f of x equals 2x plus 3 squared minus 25. Vertex, negative 3, negative 25. Transformations. I went, let's see here. The 2 is a vertical stretch by 2. I went to the left 3, and I went down 25. SpongeBob reference? What's funnier than 24? 25. You're welcome. You're welcome, children. All right. I'm going to do a quick check for mistakes. Let me pause. All right. We got a graph now from vertex form. How wonderful. So I get my vertex nice and easy. Negative 7, comma, negative 4. Remember, it is the opposite inside there. Jenny, you still you want to join here? I don't know where Jenny went. Maybe she'll come back. Axis of symmetry. It's my x-coordinate of my vertex, negative 7. Beautiful. All right, my zeros. Well, because I have vertex form, I don't even have my standard form. I'm going to set this equal to 0 and solve. So 0 equals x plus 7 squared minus 4. I should get nice answers here because I have a 4 that's going over there. So that's an awesome 7. There we go. Square root on both sides. That's going to be plus or minus 2 equals x plus 7. So I have x equals negative 7 plus or minus 2. I do like to rearrange that. So I'm going to have x equals, well, negative 7 plus 2 is negative 5. And negative 7 minus 2 is negative 9. My transformations again, I'm going, let's see here, left 7 and down 4. Cool. Let's graph this thing. Negative 7, negative 4. Right here. There's my axis of symmetry, which we'll do with a dashed line. And then I've got zeros at negative 5 and negative 9. And then, let's see here. I could get one other point. If I plugged in negative 6 to this, I would get 1 squared minus 4 is negative 3, which is right here. And some of you may even recognize the pattern of up 1 over 1, up 3 over 1. Whoa. That started off weird. It's kind of hard to write on this thing because I'm like It's like this, right? So it's on a steep angle for me. All right, I like it. That's awesome. That's fantastic. On to page number 4. Again, we're at the 20-minute mark. That's just for me, so I can tell you guys later. What is the vertex of that parabola? Well, I can just go ahead and do my x equals negative b over 2a. So the opposite of b is that over 2 times 3. So that's 18 over 6, which is 3. And now to plug back in, to get my y coordinate, because I have my vertex is going to be 3 comma something. I don't know what that something is. But if I do f of 3, I have 3 times 3 squared minus 18 times 3 plus 22. What's that going to equal? Let me look at my key. It's going to be negative 5. Done doing math for now. Well, kind of. All right, wonderful. Cool. There it is. Classify the roots of the function. So I actually don't need to solve this. All it's asking for are there 2 reals, 1 real, or 2 complex. I'm going to use my discriminant for that, b squared minus 4ac. So if I calculate that, I have 10 squared minus 4 times 1 times 35. Now, I can already tell that this is going to be a number that is negative, right? 100 minus 4 times 35, that's a more negative number than 100. So what it ends up being is negative 40, which is less than 0. So that means 2 complex solutions. Since this didn't even ask me for what the discriminant was, I could have looked at this myself and just been like, oh, dude, that's negative. So that's going to be 2 complex, okay? Awesome. All right, the graph of c of x equals 4x minus 3 plus 2x squared opens which way? Well, according to my positive quadratic term here, it's going to open up. What is the y-intercept of, what is the y-intercept of f of x equals negative, or equals 4x squared minus 2x plus 10? If I substitute in 0 for all of my x's, that bad boy right there, 0, 10. Right? The x's are going to go away. I'm left with 10. I'm done. Make sure you write it as an ordered pair. If you just put 10, half point off. We don't want those half points because half plus a half is a whole. And if you do that multiple times, you're going to have multiple points up. We don't want that, right? Do you want that? Do you guys want that? I don't think you want that. Okay, back to this. Woo, now I'm down here. All right. Simplify. Let's switch colors, shall we? I need to multiply by the complex conjugate. I'm going to zoom in. It's a little small. Square root of 3 plus 2i. Cool. And then square root of 3 plus 2i. All right, if I do this, I feel like I can make this maybe a little bit. There we go. Let's go a little smaller. Let's see here. If I FOIL the first one, root 3 times root 3 is square root of 9, which is 3. And then I'm going to have plus 2 root 3i plus 2 root 3i. And then I'm going to have plus 4i squared. So that's a wonderful numerator. Then in the denominator, I only have to worry about the first and the last terms, right? So I'm going to have 3, and then it's going to be minus 4i. So let's continue on. I hate doing sideways math, but hey, that's the room I got right now. So let's see here. This, let me choose a different color here so we can see it. That's going to be negative 4, right? Because I squared is negative 1. So 3 minus 4 is going to be negative 1. Oh, Jenny, in a little bit. She's whining. All right, 4 root 3i all over, and then, oops, that's supposed to have an I squared. My apologies. That's going to be plus 4, so I'm going to have 7. So in the same regard as the last one, that becomes positive 4. All of it, okay, including that negative. So now for my final answer, I'm going to rewrite this as negative 1 over 7 plus 4 root 3 over 7i. Two separate terms there. Some will accept it as the previous step. I like to write it as two separate just because it says that it's a plus bi. What is the conjugate of 3 minus 5i? Well, we just did something like that, right? It's 3 plus 5i. We just changed the sign of the imaginary term. All right. The zero of the function is where the function crosses the y-axis. True or false? That's asking you a true or false. That would be false. Okay? The 0 of the function is where it crosses the x-axis. I thought there was a true or false on there, but apparently it didn't show up on mine. Okay. Simplify. All right. Got to be careful with these, right? You only did a few of these in class. So, and I'm going to change from orange now. I'm going to go to blue. All right. Square root of negative 36 is 6i, right? Negative inside the square root is an I. And then we got our square root of 36. Same regard, same idea here for the square root of 100. So now I have 60i squared, which is going to be negative 60. Cool. Awesome. That is my final answer. Now I want to FOIL these next two. And we've already done something like this, right? We did it in the other problem. It was a little more complex, but hey, let's go for it because, it's awesome. All right. So I've got 20 minus 15i, and then plus 4i, and then minus 3i squared. Cool. All right. I don't know if I want to get to my lawn today, you guys. This is taking a little longer, but hey, it is what it is. So now I'm going to get, let's see here. This, as we talked about in the previous one, that's going to be plus 3, right? The negative, the 3, and the I squared all become plus 3 there. So I'm going to have 20 plus 3, which is 23, Michael Jordan. And then negative 15i plus 4 is negative 11i. Beautiful. Woo! All right, I changed the locations. Jane wanted to go outside, so I'm here to, keep an eye on her out there. All right, find the zeros of the function by factoring. Ooh, we've done a lot of factoring. It's awesome. Apparently, maybe it's part of the test. All right, so this has a leading coefficient. Went back to a thicker marker here. Kind of like, we're backed out a little more. All right, so I got 20, and I want to add the 9. Well, that's going to be 4 and 5. We've actually had those same numbers here recently. So I'm going to start over here. We got 2x squared plus 4x plus 5x plus 10 equals 0. So group them. And I've got 2x times x plus 2. And then I've got 5 times x plus 2. So I get 2x plus 5. It's one factor. And then x plus 2 as the other factor. So I'm just going to go right to it. X is going to equal, it's asking for the 0, so I can write it in this way. Only if it's the x-intercepts do you want an ordered pair here. And that's going to be negative 2. Wonderful. Number 24. Find the zeros of the function by completing the square. Beautiful. And with the leading coefficient. Completing the square again. Weird. Now I feel like I need to go back to the thinner marker here. I feel like I'm going to run out of room. Okay. So I'm going to rewrite it over here and move that 48 over. Okay. So I have f of x minus 48. Leave a space. I'm going to take out the GCF of 3, and that's x squared plus 10x. Leave a space. Boom. All right. So the opposite of b, sorry, not the opposite of b divided by 2, which is 10 divided by 2 squared. That's 5 squared, which is 25. That's what I'm adding to both sides. Perhaps I pop a square around that. That's what I'm adding to both sides to complete the square. Wait, that's not what I'm adding here, man. 75. How did I get that? Boom, that 3 times 25 gives me that 75. Because that's what I really added to both sides. So let's see here. F of x plus, I can't do math right now. Was it 27? No. Yes. Equals 3. And then x plus 5 squared. So my final answer, wait, no, hold up. I said find the zeros. So really I should have set this equal to 0, not f of x. My apologies. Okay. So I only need, that. Okay. Cool. So really in the initial, I wanted this to be made into 0. 0 equals 3x squared plus 30x plus 48. I did not need that function notation throughout. I apologize. I was going ham. All right. Back over here. Now I'm going to divide by 3. And I've got 9. So I'm going to erase that now. 9 equals x plus 5 squared, square root. I get plus or minus 3 equals x plus 5. So x equals negative 5 plus or minus 3. And I'm going to have negative 5 plus 3 is equal to negative 2. And negative 5 minus 3 is equal to negative 8. It asks for the zeros. That should be good. All right, apparently 24, or problem 24 is another page break, but it didn't look like that on here. So I wrote down another note for myself. All right. All right, let's see here. Find the discriminant. I need a nap, children. I need a nap. No, I need a sleep. Find the discriminant and zeros of the function by using the quadratic formula. Oh, perfect. All right, quadratic formula. I love this formula. It's really great. There's a lot of great memes with it, too. Feel free to send them my way. I do enjoy them. So let's see here. We've got the opposite of b, or wait, find the discriminant first. So the b squared minus 4ac. So my discriminant is negative 4 squared minus 4 times 15 times 1, right? It was 15 and 1. Beautiful. So that's going to be 16 minus 60 is going to give me negative 44. Okay, so that's my discriminant. Now let's go into the quadratic formula. So with the quadratic formula, it's the opposite of b. Right, it was negative 4. Yeah. Plus or minus the square root of b squared minus 4ac. Well, I already figured that out. That's negative 44. All over 2 times a, which was 15. Cool. Let's keep moving sideways because there ain't enough room. I got 4 plus or minus. Now, if you remember, and I'm going to make this radical a little bit smaller and scooched over. Hold on. If you remember how to break down your radicals, I'm going to ignore that negative for now. I know that's going to be an I, right? I would have 4 and 11, which would simplify down to 2 root 11. So 2i root 11 over 30. All right, so everything can be reduced here by 2. So I'd have 2 plus or minus I root 11 over 15. Never reduce inside that radical when you're reducing like all the constants that are out there, okay? Just like if you had like 2x, you wouldn't divide the x, but you would just divide the coefficient 2 by 2, okay? So you shouldn't be dividing in there. Not that we could with 11, but you cannot because it's in the radical. That is our final answer there, our finished product, if you will, after solving using the quadratic formula. But actually, I would prefer it. We would accept it there, I think. You know, I mean, it would be a little, that's fun. But you know what? Let's write it properly. 2 over 15 plus or minus, and then it would be root 11 over 15 I. That would be our final one. What, Jenny? What? You just came back in from going outside, and now you want to go back outside? Yeah? All right, I guess I'll let her out. All right, application problem. The function f of x equals negative 37x squared plus 102x plus 42 models the height in feet h of t where t seconds after the ball is thrown upward. We must be on some other weird planet because we don't have negative 16t squared. I don't know. Maybe it's Mars. Maybe it's the moon. Less gravity. I'm not sure, man, but whatever. Find the maximum height attained by the ball. Let's bust out those TI-84s and get after it. All right. I got my plugged in my emulator here. Boom. There we go. Wonderful. Now, if I go like Zoom 6, just our normal window, you're going to see part of the graph show up, but not all of it. We need to adjust that Y max. So let's go ahead and do that. So window, I'm going to go down to my Y max. And let's see here. It looks like it starts at 42, right? If I said, what's the starting height of this ball? 42 feet would be that starting height. So you definitely got to go bigger than that. And that's a pretty high initial velocity there. So I'm just going to go like, let's say 150, and maybe that'll work. Beautiful. Wonderful. We can see it all. Awesome. So second calc, let's get our maximum. So I arrow down to maximum, enter. I want my left bound. I'm already to the left of the maximum. I'll just hit enter. But now I got to arrow over to the right a bit. Boom. Wonderful. Got it. So it says find the maximum height attained by the ball. My maximum height would be the 112.2973. The time it took to get there is my x value. Okay, so if I said, how long did it take to get the max height? Our answer would be 1.378 seconds, or whatever it asks to round to. But for our purposes, the maximum height is 112.3 seconds. Or sorry, 112.3 feet. 112 point, we need thicker marker for that. 112.3 feet. Now, when does it hit the ground? Well, that's once again in our calculator. If I hit second calc, I want to now find the 0, right? I want to see when it hits the ground, when it has a height of 0. So I want to go to the left side of my 0. Now, it's a little bit hard to see, but it's right here. So I'm going to get a little closer. If I hit enter, then I hit enter again after I go below my x-axis. As we can see, my y values are now negative. That means I'm below it. Hit enter one more time. And boom, it's right there. It's a little hard to see. You know what? I'm going to do that one more time here, but I'm going to change my y minimum so we can see that a little better. Let's go negative 50 here. I apologize. I know I'm wasting some time here. Let's go quick. 0. Enter. Okay. Oh, it started me all the way over there again. I got to click all the way over. How you guys doing? I'm just working with the calculator. Oops, went too far. Okay. That's the left side of my 0. Hit enter. The right side. Oh, I'm already below. That's fine, or I'll go a little further. Now, we see the arrows are pointing in. Hit enter one more time for our guess. Boom. I get 3.12 and then 0. As you saw in the other one, it had like an E and then like a negative 12. That means it's super duper close to 0. Sometimes your calculator is just a little off. It is estimating. So 3.12 seconds. 3.12 seconds. All right, on to the next page here. We got 3640. Cool. Wonderful. Fantastic. Solve the quadratic inequality. Ooh, this is some new stuff here. This is some new stuff. Well, let's get going on it. All right. Just making sure this is that even a page break? I don't know. That's 27 though. No, that's mid-page. Sorry, it looks different on mine. All right. Cool. Let's see here. So solve the quadratic inequality. Looks like we can factor that. We have all these with 20 and 9s. All right. Anywho, 20, negative 9, that's going to be negative 5 and negative 4. So when I factor this, x minus 5 and x minus 4, I'm going to set that equal to 0. Now I'm going to find out when it changes, when it's 0, because around that 0 is where it's positive or negative. And in this case, we want it to be less than or equal to 0. So negative or 0. Okay? All right. So I'd have x equals 5 and x equals 4. So to do this, I'm going to go ahead and create a number line here. So 0, 4, 5. And I'm going to do some test values, okay? And when we do test values, I use this factored format. All I'm looking for is it positive or negative, okay? So if I'm going to test a number that's less than 4, a real easy number would be 0, wouldn't it? I know it's not right next to 4, but 0 is super easy. If I plugged 0 in here, I would get negative 5, or just a negative number. Here I'd get another negative number. What's a negative times a negative? Well, that's positive. So negative times negative equals a positive overall. Cool. Now that would be for this area. Now for my next one, I'll use a different color. So if I plugged in, say, 4.5. Well, 4.5 into the first factor is a negative number. Into the second factor, it's a positive number. So negative and positive. That's overall negative. Okay? And then my last one, I'll go purple. If I plug in, say, 6. 6 is larger than 5. So here what I got is, let's see here. 6 would give me positive in the first, positive in the second. So positive gives me overall positive. Beautiful. So what do I want? I want it to be less than or equal to. So that means I am in this area here, solid because equal to, and then shading between. To write that as a compound inequality, it'd be 4 is less than or equal to x is less than or equal to 5. Boom, done, awesome, moving on. All right. Graph the following quadratic inequalities. Show your work. Let's do it. Okay. So first I want to find my vertex here as it asks. I don't know why that won't go away. Please go, I don't know the dash lines. All right. So I'd have x equals negative, opposite of b, negative 8 over 2 times a, which is 1. So that's going to be negative 4. So negative 4, comma, and then when I plug that back in, I get negative 25, which is off the graph. So I'm going to have to scale this by some smaller numbers here. Let's go with negative 5, negative 10, negative 15, negative 20, negative 25. Cool. All right. And then, let's see here, boom. I'm actually going to need to scale the other one as well. I'm going to do that while I'm clicking through markers a million times. We're going to go by 2's here. Negative 2, negative 4, negative 6, negative 8, negative 10. All right, back to the orange and a thicker marker. All right, so if I plot that, negative 4, negative 25, that's right down here. Now I want to find my zeros. In order to do that, how about I try factoring? If it factors, awesome. If it doesn't, I'll try something else. So I'll set that equal to 0, and I get x squared plus 8x minus 9. If I factor, that's going to be x plus 9, and then x minus 1. So I'm going to get, I don't need that. How about, let's see here, negative 9, and x equals positive 1. Cool. Lovely. So x equals negative 9, x equals 1. So negative 9, positive 1. Awesome sauce. If I wanted to, I could even add another point here that's negative 9 right here, and I could even reflect that over, right? I could reflect that over here. That's my axis of symmetry. Right about here. Okay. Now, is this a solid or a dashed line? Well, it is a solid line because it's less than or equal to. There we go. But I got a shade, right? It's an inequality. A lot of times people are like, hey, do I need to shade? Should I shade on this problem? Do I need to shade on this problem? If it's an inequality, you got the shade. And it's less than, so I'm going to go below that parabola. Okay? Cool. Awesome. I look at my vertex. I go below, so it's outside of that parabola. All right, I went outside the video. Sorry. Okay, moving on. This one. It's in vertex form. I'm going to change colors because I'm crazy. I'll go this one. All right. So my vertex is negative 1, comma, negative 2, and my zeros I can calculate by setting it equal to 0, as I could use an equal sign perhaps. There we go. X plus 1 squared minus 2, so I get 2 equals x plus 1 squared, take the square root. I get plus or minus the square root of 2 equals x plus 1. Subtract 1, so I'm going to get x equals negative 1 plus or minus the square root of 2. Cool. Awesome. And then I'm going to graph it. So negative 1, negative 2. And let's see here. I'm going to plug in. I don't want to graph negative 1 plus or minus the square root of 2. That sounds awful. How about I plug in, let's see here. How about 0? If I plug in 0, I get 1 squared, which is 1 minus 2 is negative 1. So reflect it over because that's my axis of symmetry right here. And then if I plugged in 1, I'd end up with 2. So this time it's a dashed line. Don't miss that. And it says y is greater than. So if I look at my vertex, I want to shade above that, which then puts me inside the parabola. Yay! Cool. Cool. Awesome. Let's keep going. Almost done here, children. Almost done. 4 more problems, and then I don't think I'm going to get to mowing the lawn at 6 o'clock now. I'll probably anger the neighbors. You know what I mean? All right. So, oh well, grass is going to grow a little more. I want to write a quadratic equation with the given roots. Write it in the form ax squared plus bx plus c equals 0, where a, b, and c are integers. So I'm going to start with my factors here. Now, this can be a little confusing. I think for the negative 4, it ain't too bad. I have x plus 4. The other one's a little weird, so check this out. If you have a tough time backwards thinking, I have my roots. That means that x equals 2/3. Well, if I multiply by 3, I got 3x equals 2. And then if I subtract 2, I get 3x minus 2 equals 0. This is my factor. I just kind of like backwards worked it, right? If I wanted the roots, I'd take my factor and set it equal to 0. If I want my factor, I'll set the root, blah, blah. Okay, yeah. All right. Wonderful. So that's factored form. It asks for ax squared plus bx plus c. That's standard form. Multiply it out. So I get 3x squared, and then I'd have negative 2x, and then plus 12x minus 8 equals 0, and then 3x squared plus 10x minus 8 equals 0. That's the form it wanted. I'm done. 3 more. Hydration. Cool. Roots. All right, this time it's both of them I have to work with. Oh, how rude. I'm going to start up here where there's more space. All right, 0 equals. And then I'm going to have x, not x. I'm going to have, let's see here, 6x plus 5. And then I have, let's see here, 2x, because that's what I'm going to be dividing by, minus 3. So if I multiply these out, I get, let's see here, 12x squared minus 18x plus 10x minus 15. And then I've got 12x squared minus 8x minus 15 equals 0. Coolio. All right, last couple. Write the equation in vertex form that passes through the given points. So this is my vertex, which means that this is h and this is k. My point is then x, comma, y. And I can use the form y equals a times x minus h squared plus k. I'm going to plug everything that I know, and I'm going to solve for what I don't, which is a. So I have 3 for y. I don't know for a. For x, I have 2. For h, I have 4 squared plus, and then for k, I have negative 1. So I'll just do minus 1. Now I get to work. 3 equals 2 minus 4 is negative 2 squared is positive 4. So 4a minus 1. I'm going to add 1 over. I get 4 equals 4a. So a equals 1. My final answer then is, and I'll change colors so it shows up better, y equals 1a. All right, so 1 for a, so I'll put nothing there. X minus 4 squared minus 1. This would be my final answer. If you threw a 1 right here, that's cool too. I'm not going to do it because I don't like how it looks, right? I don't need it. If I don't need it, why am I going to throw it there? All right, last one. Let's do it. Okay. I'll change colors again because I'm crazy. Ooh, I got an idea. All right. Vertex. H, comma, K. Yes, this is the grand finale. If you could not tell, Mr. Allen, it's getting loopy. It's getting tired, right? All righty. So I have y is 1 equals, and then we have a, which I don't know, and then we have x, which is 0 minus 3 squared. This is kind of hard to read. I regret this immediately. I'm going to try the other one. That one might show up a little better. Okay. So now, let's see here. We have 1 equals, that doesn't show up much better. That's 3 squared, which is 9 minus 4. So you could do a times 9, or you could do 9a. I think we might like that better. Maybe we'll even like this one better. All right, add 4. Add 4. I get 5 equals 9a. What am I going to do? X. Silly Mr. Allen. What am I going to do next? I'm going to divide by 9, or I'm going to use a new marker too because I want to use all these now. Divide by 9. And I get a equals 9 or 5/9. Okay, so my final answer here, my final answer, and I'll use one more marker here. I guess this one looks fun. All right, we get y equals 5/9 x minus h, which is 3 squared minus 4. There's our k. Whew. All right. Well, there's 49 minutes of my life I'll never get back. Actually, longer with pauses and trying to get Jenny to be a part of it, which she is outside. But I hope this helps. I hope you guys are able to skip through and actually use it, or otherwise I just waste my time. But hey, hopefully you used it. Can't wait to see you guys tomorrow. Have a wonderful day. American Freedom, rock and roll, Costco, and of course, Yoro. See ya.